Now let's discuss the behavior of different copulas based on the Kendall's tau parameter, looking at how point distributions vary for each copula function. For example, if the Kendall's tau for the Gaussian copula is negative but relatively strong, you can observe a significant clustering of points with a clear downward slope. On the other hand, if Kendall's tau for the Gaussian copula is high and positive, you'll see the opposite. There is still noticeable clustering, but this time, large portions of the plot are empty. For instance, the upper left corner has no points, and the same is true for the lower right corner. This pattern indicates a strong positive correlation between the variables. Now, moving to the T copula. The behavior here is similar to the Gaussian copula. A low and negative Kendall's tau models a situation where variables x1 and x2 are negatively correlated. On the scatter plot of u1 and u2, this is represented by strong clustering, but the bottom left corner and the top right corner of the plot remain largely empty. This shows the structure of the negative correlation. Next, let's consider the Clayton copula. The Clayton copula specifically models dependence between two variables in their lower tails. It captures the relationship between x1 and x2 when both take on low values in their distributions. These values can be positive, negative, or even mixed in sign, as long as they are low. The focus is on studying correlations in the lower tails. If Kendall's tau for the Clayton copula is low, the scatter plot shows a lot of dispersion. There's no visible pattern to indicate any significant correlation. However, when Kendall's tau is high for the Clayton copula, the correlation in the lower tails becomes very strong. In this case, the points in the lower left corner of the scatter plot overlap almost completely, demonstrating a strong relationship between x1 and x2, represented here by u1 and u2. In contrast, the upper right corner may still show some clustering, but it is far less pronounced than in the lower left corner. This is because the Clayton copula is specifically designed to model relationships in the lower tails, focusing on low values of x1 and x2. Finally, let's look at the Gumbel copula. The Gumbel copula has Kendall's tau ranging from 0 to 1. It is used to model relationships between random variables in their upper tails, focusing on high values of x1 and x2. When Kendall's tau is small, the scatter plot shows a large dispersion of points, much like in the Clayton copula, with no discernible pattern or structure. However, when Kendall's tau for the Gumbel copula is high, nearing 1, the behavior changes dramatically. In the upper right corner of the scatter plot, corresponding to high values of x1 and x2, and thus u1 and u2, the points almost completely overlap. This indicates a very strong upper tail dependence between the variables. The relationship between x1 and x2 becomes extremely pronounced when they take on large values. In summary, each copula demonstrates unique characteristics based on the value of Kendall's tau, highlighting different dependencies between variables in either the lower or upper tails of their distributions.